Okay, so right now we're going to go ahead and we're going to do sum and differences for tangent. Tangent's a little bit more challenging if you're not careful than sine and cosine. So let's go ahead, let's take this whole big ugly equation and split it up. So if I have tangent alpha plus beta, so that's my top one here, so I'm going to use my top one here and my top one here. That means I have tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Okay. For the second one, I got a subtraction sign on the bottom, subtraction sign on the bottom, and I got a plus sign on the bottom there. So I've got tangent alpha minus beta is equal to tangent alpha plus, minus tangent beta is over 1 plus tangent alpha tangent beta. So those are your two equations for the sum and differences for tangent. Okay, so let's go ahead, let's do one of these real quick. So if I was to give you to find the exact value of the tangent of 225, well, that's already on our unit circle down here. But let's go ahead and use this equation to go ahead and show you how it works, okay? So if I'm going to go ahead and do this, if I follow the rules that I showed you for sine and cosine, you do 225 minus 45, and you'll get 180. So basically what I mean is you will do tangent 180 plus 45, where this is alpha and this is beta, okay? I like to write off to the side what my tangent values are, so the tangent at 180 and the tangent at 45. Let's talk about that real quick. So if we look at our unit circle right here, we need to know what these values are for tangent all the way around our unit circle. More than likely you don't. But right here we have 0 divided by 1, so that's going to get us 0. Here I have 1/2 divided by square root 3 over 2, which is going to get me square root 3 over 3. Here I have square root 2 divided by square root 2, gets me 1. Here I have square root 3 over 2 divided by 1/2, and that's just going to get me square root 3. Here I have 1 divided by 0, so that's undefined. And these are the only possible 5 answers I can have for tangent all the way around my unit circle, except sometimes they're negative. So here, if I was just to, hot dog fold this right on over, right here, this would be negative square root 3, this would be negative 1, this would be negative square root 3 over 3, and here's 0. Again, if I folded it over right here, so this one right here is negative square root 3 over 3, so this one is going to be positive square root 3 over 3. Positive 1, positive square root 3, undefined. Okay, and over here I have negative square root 3, negative 1, and negative square root 3 over 3. And just like that, I have my tangents all the way around my unit circle. Okay, so right here, my tangent at 180, well, that's right here, that's 0. And then I also need my tangent at 45, which is 1. So I have 0 and 1. So here at 180, it equals 0, and here at 45, it equals 1. So I'm going to go ahead and substitute those values in, and I'm going to write this into my equation. So I've got tangent 180 plus tangent 45 over 1 minus tangent 180 times the tangent of 45. Okay? So now I'm going to substitute these in right here. So tangent of 180 is 0. 45 is 1. Got 1 minus, and then tangent of 180 is 0 times the tangent of 45, 1. So this ends up getting me 0 plus 1 is 1. Here I have 1 minus 0, so it's 1. So there we go. We got 1. And that's exactly what we said that was going to be right here at 225. It is 1. Ooh, I don't know why that grew so weird. But at 225, it's 1. Okay? So let's go ahead. Let's try a different one. Let's do tangent of 13 pi over 12. All right, so same thing. We're going to try the same idea as what we did before, where we're just going to take it and we're going to subtract pi over 4. Oh, not equals, minus. Okay, minus pi over 4. That's times 3 times 3. So that's going to get me 10 pi over 12. Okay, that's going to reduce. They're both divisible by 2. So then that's going to become 5 pi over 6. And sure enough, 5 pi over 6 is on our unit circle right here, 150 degrees. Okay. Now, I'll talk about it in another video, but we don't want to use the pi over 6s. We don't want to use these. We don't want to use them because their tangents are square root 3 over 3, and that makes it really, really, really difficult to do these. So I just got 5 pi over 6. I don't want to use that one. So my next option to go ahead and do this is to instead try 13 pi over 12, and I'll subtract the next pi over 4, which is 3 pi over 4. So times 3 times 3. So that'll get me 13 pi minus 9, which is going to get me 4 pi over 12, which these are both divisible by 4, so I get pi over 3. Pi over 3 is okay. I didn't mark that out. I can use that one. So that's the one that I'm going to go ahead and do. So right here, I'm going to turn this into tangent and do pi over 3 plus 3 pi over 4. Okay? So here, what I'm going to do is I'm going to put this in my equation, which is tangent pi over 3 plus tangent 3 pi over 4 over 1 minus tangent pi over 3 tangent pi over 4. Oops, sorry, 3 pi over 4. All right, so we got the tangent of pi over 3, I just showed you, is square root 3. We got the tangent of 3 pi over 4. It's in my second quadrant, and it's a pi over 4. So all the pi over 4s are always 1. My second quadrant, it's going to be negative 1. Okay, so I'm going to go ahead and substitute all this information in. So tangent pi over 3 is going to be square root 3 plus tangent 3 pi over 4, negative 1 over 1 minus tangent pi over 3, square root 3 times negative 1. So I'm going to go ahead and rewrite this a little bit so it looks a little bit nicer. So square root 3 times negative 1 is negative square root 3. 1 minus negative square root 3 is going to be 1 plus square root 3. Okay? So now I have this. Now, I can't have square roots in my denominator, so I have to rationalize this. In order to rationalize this, I have to multiply by the conjugate of the denominator. So that means that I'm going to take the denominator and I'm just going to change the sign in the middle. So instead of plus, I'm going to do minus. If this was a minus sign here, I would do plus over here. So I'm going to multiply by 1 minus square root 3 to both top and bottom. Because what I do to the top, I must do to the bottom. What I do to the bottom, I must do to the top. So I'm doing this all to get rid of the square root in the denominator. That's what rationalizing means. So I'm going to go ahead and I'm going to FOIL these out. So, all right. So I've got square root 3 times 1 gets me square root 3. I've got square root 3 times negative square root 3 gets me negative square root 3. Oh, just kidding. I need to go to bed. Square root 3 times negative square root 3 is negative 3. All right, negative 1 times 1 is going to get me negative 1. And then I got negative 1 times negative square root 3, so that's going to give me positive square root 3. Okay, so that's my numerator. I'm going to do the same thing to the denominator. I'm foiling. You can use box method if you want to. I just personally hate box method. All right, I got 1 times 1 here, so that's 1. 1 times negative square root 3 is negative square root 3. Square root 3 times 1 is positive square root 3. And then square root 3 times negative square root 3 is negative 3. So if we go ahead and combine like terms where we can, up top, I can combine the square root 3 and the square root 3 here. Square root 3 times, or plus square root 3 is just like having x plus x. It becomes 2x, right? So that becomes 2 square root 3. Negative 3 minus 1 becomes negative 4. Okay. On the bottom, 1 minus 3, well, that becomes negative 2. Negative 3 plus 3, hey, those cancel out. And that's what we wanted to do. We wanted to get rid of those square roots in the bottom. So we did exactly what we wanted. Now I just have this ugly looking fraction that I need to reduce. I have two things right here. So really, 2 square root 3 over negative 2 becomes negative square root 3. Negative 4 over negative 2 becomes positive 2. And there is my answer. That is your tangent for this one. So if you needed to, if you don't like to do the pi over 4 and the 3 pi over 4, you can turn it into degrees and you can work with it that way. That's fine. It'll get you the same thing. I just prefer to keep it in radians if I can.